Woohoo, we're live. This is Math 60, Intermediate Algebra. We're doing 9.3, talking about exponential functions, exponential graphs. And we just finished looking at x squared, which is a parabola, not exponential, and 2 to the x, which is exponential. And I wanted to compare that to a different kind of exponential. So you can have, remember your base here, y equals b to the x. B can be anything that's positive as long as it's not equal to 1. And so I pick 1/2. Now, 1/2 has an interesting shape. It's the same basic shape, but it looks like it's flipped around. Let me remind you of what 2 to the x looks like. 2 to the x goes swoop up, and 1/2 to the x goes swoop down, which is really interesting. Well, at least I think it's really interesting. Let me add some arrows because, I can't help myself. These things have to have arrows. Now, a couple things. Let's look down here first. The domain is all reals. Domain is all reals. Range, y is greater than 0, y is greater than 0. That's the hallmark of exponentials. There's an asymptote, but the asymptote kind of, even though the line itself is still the asymptote, that x-axis is the asymptote, even though it's the asymptote, they're asymptotic kind of in different directions, right? 2 to the x is asymptotic towards x is negative infinity, right? Off to the left. And this is asymptotic off to the right, positive infinity, which is kind of cool. The y-intercept is the same y-intercept. It's that point that I said was so important to exponentials, as long as they're plain exponential. If you go and get fancy with all of, the ribbons and buttercream icing and everything, then it's going to be, you can move it around. But the basic function is going to go through that 0, 1. Now, why is this one big on the left and small on the right? Let's look at the values. When x is 0, 1/2, move this out of the way, 1/2 to the 0th power is 1. That's true for everybody. Anything to the 0th is 1. But what is 1/2 to the 1st power? That's 1/2. 1/2 squared is 1 over 2 squared is 1/4. So as the exponent gets bigger, the y value gets smaller. So we've got this interesting inverse thing happening. As x is getting bigger, so we're going this way, y is getting tiny because it's becoming a fraction. So then the question you should ask is, why is it getting all big over here? Well, let's take a look. When you look at 1/2 to the -1, that's 1 to the -1 over 2 to the -1. Oh my gosh, bunch of vampires. Let's make everyone happy. It turns out it wasn't a vampire after all. It thought it was a vampire, but when you apply -1, it means flip everything upside down. So suddenly the 1/2 flips up on top and we get the big numbers over here on the left. So again, if you look at the two, if you compare, where is it? There we go. If you compare 2 to the x with 1/2 to the x, and you compare their values here, you'll see they move in opposite directions. This goes 1/2 and 1/4 for 1 and 2. This goes 1/2 and 1/4 for -1 and -2. This one goes 2 and 4 for -1 and -2. This is 2 and 4 for 1 and 2. So there's some interesting things happening there. So what I wanted to do was to take a look at, these two. Now you'll notice, I have to turn off the light. So you'll notice that I'm prepared for all the rest of these. It turns out fractions are just a little fidgety in Desmos, so I wanted to set them up ahead of time. And for those of you who use the app, if you click on the left side on that little circle, you make it disappear from the graph, so you can focus on just what you want to focus on. So what I want to focus on is the blue one, which is 2 to the x, that's an exponential, and the red one, which is 1/2 to the x. And notice there's symmetry. Notice they're mirror images of each other. You just took one and flipped it upside down to get to, well, not upside down, sideways, sorry. You flip it to left to right. And so this This speaks to something. It's a certain kind of symmetry, and then we say they're symmetric. And normal humans would say around, but of course, mathematicians, no, we don't say around, we say about. So they're symmetric about this line in the middle. The line that would be the stick in the middle of the gyros. If you guys are hungry right now, I'm kind of hungry. There's our gyros, and it's on this spit. The spit in the middle is the y-axis, or the line x equals 0. So these two are y equals 2 to the x and y equals 1/2 to the x are symmetric, which means that you can swap x and y, x for the opposite of x, and you get the other one. I don't know if that made any sense. I think I just said blah blah blah, but you guys are patient. I appreciate it. I'll figure out what it is I'm trying to say and then try to say it. So, having looked at those two, I want to start really comparing. So I want to compare 3 to the x and 2 to the x, 1/2 to the x, and 1/3 to the x. And then just to go completely bonkers, I want to do all of them at the same time. Okay. So the first question is, which do you think gets bigger faster? 2 to the x or 3 to the x? So let's look. 3 to the x is in green, 2 to the x is in blue. They both, notice, they both go through that 0.01. Remember I said that was a really important point for exponential functions. Notice that 3 to the x gets bigger faster than blue to the x. So green one is up above the blue graph on the right. But notice that on the left, they switch places. Isn't that interesting? Why is that? Well, when x is negative, that means we're negative exponents, we're putting the 3 or the 2 in the denominator. And 1/3 is smaller than 1/2. So they switch places, which is really important to notice. Okay, so now let's look at 3 to the x and 1/3 to the x. Interesting. 3 to the x and 1/3 to the x share that symmetry that 2 to the x and 1/2 to the x shared, right? We've got that symmetry to the left and the right sideways, that symmetry about the y-axis. So that's kind of cool. Still sharing that 0.01, very, very important point. You guys ready? Let's do them all. Wow. It's like May Day or maybe a really pretty present. Let's see if I can spread this out a little bit. So notice everybody's, there you go. Okay, they go through 0, 1. Notice that we've got the 3 to the x have an asymptote going off to the left, the 1/2. Oh, and someone's at the door, and that's even more exciting. So let me try to wrap this up. No one wants to actually talk to me anyway. Because, they say, can we talk to you about something? I say, sure. Can I tell you about math? And then they run away. It's the easiest thing. You can try it too. So what do we know? Well, 3 to the x and 2 to the x, we've got some interesting things.